Culpepper first class. When we get in, we do first 5, which is I can statements, daily social living, geography, word of the day, and math schedule.
Class.
Yes.
Mirror Sean and Daniel, please.
Follow directions quickly.
Follow directions quickly.
Rule number 2.
Rule number 2.
Raise your hand to speak.
Raise your hand to speak.
Rule number 3.
Remember your little raptor reminder on your desk told you to solve with an explanation, write a sentence, and then do what to your answer? Circle it. Very good. Okay, Miss Corman, tell us what you did.
Well, I saw that the 6 and 4 and 2, and it says the flat part finds it's 6 and it's 4 inches.
5.
So I knew that was 6 times 4, and that's 24. And it says, what is the area of her book? What does she need to do now to find the volume of the book is 2 inches? So 24 times 2, because it says that if the book is 2 inches thick.
Very good. Does anybody agree? Okay, excellent. Any questions for Carmen?
How did you figure out 6 times 4 is 24? Oh, I just said 6, 12, 18, 24.
Okay. Repeat addition or counting by. Excellent. You agree? Okay. Any other questions? No? Okay. Did anybody solve it a different way?
I did
What'd you do?
4 6 times instead of 6 4 times.
Okay. Does anybody, did you do it a different way? What'd you do?
I did 12 plus 12.
Okay, for 24. Okay, does anybody see a shortcut that we could do? Or maybe we wouldn't have to do 2 multiplication problems, or we can maybe just do 1. Rush, you see it?
6 times 6.
That would be 36, but you're getting on the right area there. Connor, what about you?
Times 6.
Not 8 times 6. We're going to still use the same numbers that we used before. Tyler? No, not 6 times 7. We wouldn't get the 7 from anywhere. Hope?
6 times 8.
Where would you get the 8 from? No, not from 48. Okay, so we did 6 times 4 equals 24, right? And then we took that and we multiplied it by 2. How can we combine these 2 problems into a shorter problem?
6 times 2.
6 times 2 times
4. Times 4.
4. Very good, okay? Because remember, some of our multiplication properties say we can change it around and multiply in any order between the commutative and the associative.
And you could multiply it without 2 numbers. You could do more.
Absolutely. Okay, very good. All right, what we're going to do is today we're going to talk, our I can statement for math is how to interpret products of multiplication. That's what you just did, okay, which is 6 times 4 times 2. And what you found was volume, okay? We're going to work with volume today in science, where our I can statement is that you can explain changes in matter. You're going to see changes in volume, and then we're going to measure volume, okay, both in liquid form and then in solid form. But to start us off, our ELA I can statement is that you can find the main idea. So first we're going to figure out what we need to know about chemical and physical changes and how matter changes, why it's important in our life, and then we're going to start talking about the actual changes and the changes in volume. Okay, so what's the main idea? I want you to talk to your partner real quick. Just turn to somebody next to you. What is the main idea?
That's a short sentence. That's a short sentence. Unless it's just no.
Class.
Yes.
Okay, so what is the main idea, everybody? Okay, and what about them?
Like what the temperature.
Like what's
going to be stored at.
Yes, very good. To prevent what?
Spoiling.
Spoiling. Okay, very good. So, when you freeze food, okay, that's just like freezing water. Is it still food? Is it still water?
Yeah.
Yes, okay. Then you can thaw it back out and melt it, and it's still food. Okay, it's changed states of matter. Okay, but it's still the same thing. Okay, whereas if it spoils, it it is then chemically altered and it is no longer good food. Okay, so this is very important in your food packaging, whether it has been frozen and melted or whether it has actually begun to spoil. Okay, so we're going to talk about physical and chemical changes like that. Okay, so what's inside the bubble? Gas. Okay, so does gas take up space?
Yes.
Absolutely. So when we get further on into the year, we're going to be able to measure the volume of gas. First, we need to talk about how to measure liquids, and then, as you already know, solids. Okay. So we're going to talk about physical and chemical changes. And the physical is the kind that you want in your food. Chemical is not, because once it spoils, it's chemical. Unless you're baking something, in which case you do. Okay. Now, let's go ahead and talk real quick about physical and chemical changes. I need somebody to be my physical change person. We'll pick a stick. See if they're here. Number 10. Leanna, come on up. Alright, Miss Leanna. Stay over here. You be physical changes. Okay, and we said physical changes are just what's on the outside. Okay, so what is this? What's it made of?
Wood.
Wood, very good. What is this?
Spoon.
What's it made of?
Wood.
Did I change it?
No.
Not what it's made of. That's a physical change. Hold that. Okay? Alright, now, if I do change what it's made of, what's it called?
Chemical.
Chemical. Okay? Number 7.
Not in here.
Not in here. Number 14.
Me.
Come on up, 14. You be my chemical change. Yeah, it was a double. Very good. Okay? Now, my chemical changes is a lot of times when we bake. So here are these scrumdiddlyumptious cookies. Okay? Now, what are these made out of? Make a good hypothesis. Dough, sugar, flour. Okay, very good. Can I get the flour back out of this?
No.
No. Can I get the sugar back out of this?
Yes. Yes.
Not what's in. I can scrape off the sprinkles on top. You're right about that. Okay?
Yeah.
But what's actually in the cookie, I can't get it back out. It's been baked. Anytime you burn or bake something, it's generally a chemical change. You can't get it back, okay? So on this chemical change, you're going to hold the yummy cookies. Okay, so what I'm fixing to do is I'm going to play with dry ice. Does anybody already know what dry ice is? I'll scientifically and safely play with dry ice, yes.
Yes.
What do you think it is, Tyler?
Dry ice is just really cold ice that can burn you if it's on your skin.
You are correct. It can burn me, so what should I wear on my fingers?
Gloves.
Gloves, okay.
Special gloves.
So I have gloves here, yes. They're lined on the inside, and then they're thermal, so that way it's not going to be too cold on me. So I do have gloves for me to wear. Okay, so good. So I'm going to protect my hands. What else do I need to know about dry ice? Like, what is it? What else could I do to protect myself? Sean?
You can wear an apron so you won't get your.
Absolutely. Okay, I don't want to mess up my clothes, so I do have my happy little apron here, okay? It's simplicity. It's a kitchen gourmet thing. Don't ask.
It's wrinkles.
I know. Aiden?
Goggles.
Wear goggles, absolutely, okay?
Don't want to burn your eyes.
So, yeah, I do not want to burn my eyes, so I do have my lovely goggles. I'm looking fantastic. But before I put my goggles on, I need to do something else. Hair, okay? Ladies.
Ladies.
Especially ladies. You
Yeah.
always need to tie your hair back, okay, so that
You
way
can't.
it doesn't,
It'll hurt.
you know,
burns
yeah, like
so
set on
hard.
fire or something. Okay, very good. Alright. Alright, don't I look awesome? I'm ready for my close up. There we go. Okay, alright, yeah, that's awesome, okay? Alright, I'm gonna get to gloves in just a second, okay? But before I get to gloves, I still need to know, what is dry ice made of? What is it made of? I'll give you a hint. It's generally a gas. Everybody? Carbon dioxide, very good. Okay, so what I have is frozen carbon dioxide. So we're going to observe it. I'm going to catch some of it so we can look at it. And then you have to tell me whether it's a physical change or a chemical change. Okay? So I'm going to put some in. Oop. Goggles. Gotta look safe. Alright. So now we're going to practice. We're going to practice another physical change. And we're going to measure its volume. Okay? So I need 2 volunteers. Let's do and Sean.
But they talk too much to each other. Hey,
Everybody calm down.
Hey.
Alright, you will need these, gentlemen.
Okay.
I never did do anything.
Okay. Tyler, you take there.
Gentle.
And
Seriously.
Sean, you pick there. Okay. On 3. Now that orange is pre-sliced. It's like I got some cuts in it to make it easy. Okay. But what you're gonna do is you are going to try to squeeze as much juice onto the plate. It has to be on the plate so I can pour it in these little containers. Okay. And we're gonna talk about who squeezed more and how we know. Okay. All right. Your job here, you and then Sierra, is to cheer on Sean. Then your table and your table, you cheer on Tyler. Okay. On your marks. Get set. Go. Alright, so let's see who squeezed some more juice. Okay. Now, what would you normally measure volume with?
Measuring cup.
Okay, measuring cup. What if I wanted to be more scientific about it? Graduated cylinder. Very good. Okay. Alright, so I have mini graduated cylinders because I don't have a lot of liquid to do. So I have mini graduated cylinders that are pre-measured out. Okay. So I'm going to pour the juice in there.
Don't spill one.
Sharper in here.
Yeah, I'll get these out.
Okay.
Where did I go?
Tyler, tell me how much is in there.
3 milliliters.
3 milliliters. Very good. How'd you know that?
Because on the little graduated cylinder, the liquid goes up to 3 milliliters.
Back to how we measure liquid. Okay. Whenever you're measuring volume of a solid, okay, you're going to measure 3 things. You're going to measure length times width times height. Okay, and that gives you volume. Okay, so that's simply 3-factor multiplication. That's what we started the day with. 6 times 4 times 2. That's how you would find the volume of solid. Okay. All right, I have a tic-tac-toe for us to do. Let me tell you real quick how you're being graded today. Of course, your daily work as always. We'll take a CPS quiz in just a few minutes. It's 1 point per question. Before I have you do the tic-tac-toe, I do want to do a rally coach with a partner. This is just on physical and chemical changes. So I'm going to let you pick, sit at your desk and do this with somebody. Then when you're done, this is worth 15 points. So each side is worth 7. And then your name is worth a point. Let's see what else to say. This is your group work. And then you're going to do a tic-tac-toe, which is your individual. Okay? We'll close with the CPS in just a few minutes. Any questions about this?
Okay, burn a piece of paper.
Alright.
When you burn a piece of paper, you don't get. Oh yeah, when it says burning or baking, it has to be chemical.
You can't use that to
Making orange juice.
Making orange juice.
It's
burning it.
Because it's still, when you make it, it's made out of the same thing.
And burning gasoline, that would be chemical because it's burning.
And it changes it into
An example of a physical change is A, tearing a sheet of paper, B, burning a candle, C, burning a piece of paper, or D, making toast. Alright, very good. Most of you got that right, tearing a sheet of paper. It's still a sheet of paper, it's just doesn't look sturdy. Final closing activity is going to be, I'm going to give you a note card, and I want you to, from today, it can be either the math part or the science part, I want you to come up with a test question that you think should be on a test about either multiplication like we've been doing, or about physical and chemical changes. It can be multiple choice, it can be fill in the blank, it can be short answer, whatever you want it to be. When you're done, put it in the bin.
Are you gonna put it in the test?
Possibly.